what are some popular metrics to evaluate recommender systems? Now, when we talk about metrics, you can have offline metrics and live metrics. We are talking about offline metrics that do not involve deploying the recommender system and getting live feedback from users. Okay, so when we talk about offline metrics, the kind of metrics that we use will depend on the type of the recommender system. There are two main types. One is the explicit feedback recommender system. In this type of recommender system, the user gives a score between, let's say, 1 and 5 or 1 and 10 for each recommendation, for most recommendations, and that is the label data you have. So the users have given a score for some of the items, and then for a new user item pair, you have to predict the score the user might give. An example of this kind of a recommender system is a user giving a score like this is, suppose you have a pizza delivery guy who's coming and delivering food, and they ask you to rate the quality of your experience, or you are asked to rate the quality of your experience when you leave a restaurant, and you might give a rating between 1 and 5 on an online app through which you booked. So these are some examples where the user is explicitly giving a numeric rating, and the kind of metrics that you can use in this case are pretty similar to regression metrics, because essentially what you're doing is you're predicting a rating for that particular user item pair, for a new user item pair, while you have ratings for a lot of other user item pairs where the user already rated the item. Right? So you can use metrics like mean absolute error, mean square error, root mean square error, or some of the other regression metrics you know. The other type of recommender systems are implicit feedback recommender systems. Here you do not have an explicit user rating for each recommendation, but you could have some kind of implicit feedback from the way your system behaves. So for example, suppose you are looking at a product on one of the e-commerce sites, and you are shown a list of related products. Now you may or may not click on some of these products that are shown. So if you clicked on any of these related products, it means that product was relevant. If you did not click, it was probably not relevant. So the click is an implicit feedback given by the user, and it is not explicit. So for implicit feedback recommenders, it's a bit like the classification problem, where you have a 0 or 1 kind of feedback, either the user clicked or did not click, instead of a numeric feedback. So the difference though is that you also want to know not just whether relevant items were recommended, but whether relevant items were recommended in the right order. Ideally, you want to recommend more relevant items at the top and less relevant items at the bottom, even among the set of items that are recommended. How do you measure that? So the first thing you can think of is precision and recall, similar to classification. So precision in this context would be the number of items that were recommended that are actually relevant. The fraction of items recommended that were relevant. That's precision. Recall is out of all the relevant items, how many were recommended. Now, instead of measuring precision at K is more frequently used. So what this means is, let's say K is 3. What fraction of your items recommended are relevant within the first 3 items? If K is 5, out of the first 5 items that are recommended, what fraction of them are relevant? Now, suppose your precision at 1, suppose K is 1, and your precision at 1 looks great, you got a good score. It means that the first item you're recommending is relevant in most cases, and that's actually a very good sign. But if not that, if you don't have a great score for precision at 1, are you able to at least get relevant stuff in the first 3 items? So if precision at 3 is the next thing you might see, right? Now, instead of using precision at K, it's customary to use mean average precision, which is just the average of this value for different values of K and over different users typically. right? Similarly, you can define recall at k and mean average recall. Now, there is a special case here of implicit feedback recommenders where the user selects just one item. An example of this is, suppose you are trying to check out an object in a departmental store by scanning the object and you want to identify the object from the catalog. There is only one correct match. Now, if you're shown a bunch of products, you're hoping that the correct product is shown in the first few and you'll only click that. And this is an example where the user selects only one item or where there is only one relevant item. The kind of metrics used for this are slightly different. And the typical metric used is the mean reciprocal rank. So what you want here is that the correct item is ideally shown as close to the top as possible. So the mean reciprocal rank is just the reciprocal of the rank of the correct item. So if the correct item is shown in the first place, its rank is 1, so you get 1 by 1, so your MRR is 1. Your reciprocal rank is 1. If your item is shown at the second place, then the reciprocal of your rank is 1 by 2. And if it's shown at the third place, it's 1 by 3 and so on. The lower it is, the lower the value. Mean reciprocal rank is the mean for all the different data points or all the scans you do. To summarize, we looked at popular metrics to evaluate recommender systems. We looked at two main types of recommender systems and offline metrics to evaluate them. So the first is explicit feedback recommender system where the user gives an explicit rating. And the kind of metrics that are used are similar to the regression metrics. The other type was implicit feedback recommender systems, and we looked at a bunch of metrics like precision at k, mean average precision, and so on. And we also defined a subclass of these kind of systems where you have only one item that is relevant in the set of items shown. And for these, you typically use something called the mean reciprocal rank. Thank you.